Watson.
You've probably noticed that in the past 10 or 15 years, the popularity of forensic science, especially as it's portrayed in books, television shows, and movies, has exploded. If you're one of the millions who watch these investigations on screen, have you ever wondered how accurate the portrayals of forensic science really are? Popular media has always featured things that we would now call forensic science. From Shakespeare's poisonings, the great Sherlock Holmes, Silence of the Lambs, and the many iterations of CSI. But in this course, we'll examine some real forensic casework and the technology, science, and sleuthing used to unravel it. We'll see that Hollywood sometimes gets it dead wrong, pun intentional, especially in some things like timing and looks. I'm here to tell you that young starlets in high heels are not your typical death investigators, and we definitely don't get our DNA results back after the commercial break. I'm Dr. Beth Murray, and I've been a practicing forensic scientist since 1986 and a college professor since 1989. Because of that, I like to say I was forensic before forensic was cool. My main involvement in the field of forensics is as an anthropologist, and most of what I do involves bones. But during my many years of experience, I've interacted with and learned from lots of fellow forensic experts. I also teach a survey course about forensic science that covers something about all the specialties you'll learn about in this series. One of the things I've learned over the years through my many different interactions with others in the field, and from working lots of types of cases, some suspicious and some clearly criminal, is that forensic science is very interdisciplinary. I got my PhD through the Department of Interdisciplinary Studies, and I've always been intrigued by how a single problem is approached from multiple directions. If you ask most of the general public what the term forensic means, you get lots of different answers. But I imagine the most common misconception is that many people think forensic science is mostly about criminal activity leading to death. In fact, because of the emphasis on death in today's big and small screen Hollywood interpretations, plenty of people probably believe that forensic equals death. But those of you who are my age or older might remember that when we were in high school, the quotes forensic team was not a hip group of criminal investigators, but rather the kids in the debate club. That's because the word forensic actually comes from the Latin word for public, which is forum. So to use the term forensic actually means that something is open to public debate or up for public interpretation. Because the legal system is founded on debate and argument, what forensic science really means is to use science to inform legal matters, and that includes both criminal and civil issues. But it's important to remember when talking about forensic science that while legal systems may differ in what is or is not considered criminal activity throughout the world, what constitutes good science does not. Good science is universal. That's because science isn't really a thing. Science is a process. I like to tell my students, science is not truth. If you want truth, go down the hall to the philosophy department. Science is really a search for information that helps us explain our world. Science isn't a bunch of facts that are static. It's really a way of learning about our universe. Okay, those of you who had horrible science classes in school probably remember something like this. The teacher comes into the room and writes a list of 20 words on the board, and your job in science class that day is to write the definitions of those words on your paper. Hello, that is not studying science, that's studying vocabulary. Sure, we need to have common terminology so that we can understand each other, but come on, that's not the heart and soul of science. Those of you who had incredible experiences in science class like I did, and maybe that makes all the difference in the world. Well, those of you who had a great time, you probably remember doing some awesome lab experiments. And I have to say that understanding the inner workings behind stuff you see every day is something that still amazes me. If you were like me, you ordered the sea monkeys out of the back of the comic book, and you took your radio apart, and you poked around in the woods every chance you got, because that, my friends, is how a scientist grows up. Okay, for those of you who forgot, let's do a quick review of how you do science. We call it the scientific method, right? Now come on, wait, don't turn the video off just yet. I promise this will be as quick and painless as I can possibly make it. Basically, the first step in the scientific method is to make some type of observation about something, like a plant growing really well in a certain part of your garden. Then the next step is to generate what's known as a hypothesis. That's your initial attempt to explain your observation. Hey, maybe this plant's growing really well because it's getting plenty of sun. Or in my case, maybe it's growing really well because that's the spot where I buried my cat. Next, if you want to test your hypothesis, you're going to have to do some experiments and collect some data. That might be simple, or it could get pretty complex. Depends on the nature of your issue at hand. Then you have to analyze the results of your experiments and compare them to your original hypothesis. If the conclusions from your experiment match up to your hypothesis, then you might have a handle on the best explanation for the thing you're trying to understand. But on the other hand, if your experiments don't support your hypothesis, you need to throw out your original hypothesis and come up with another explanation for the thing you're trying to understand. Now, this might sound pretty sophisticated, but think about how often you really do use the scientific method in your everyday life, whether you realize it or not. You walk into your house, you flip on a light switch, and the light doesn't come on. There's your observation. Now you create a hypothesis as to why the light didn't come on, and then you test it. The bulb might be burned out, the lamp might be unplugged, or there may be a blown fuse. All those are testable hypotheses that we automatically come up with because in general we're all curious beings, and when it comes down to it, we're all pretty good problem solvers. You can probably think of a dozen more examples of how we're all natural-born scientists. You try to start your car and it doesn't work. You follow a recipe by the book and it doesn't turn out right. Your dog refuses to use his front paw. Your grandchild's unhappy. These are all typical observations that we generate possible explanations about. And those explanations could be called hypotheses, though we don't usually use that word. Every day, at home or at work, in restaurants, airports, grocery stores, we make observations and invent explanations for them. Some of these hypotheses are testable, while others aren't much more than sheer speculation. So, what does all this have to do with forensic science? Well, as I often tell students who think they're going to be crime scene analysts, but don't want to take chemistry or physics, in order to be a forensic scientist, you have to first be a scientist. I like to say that forensic is the adjective, but science is the noun. Forensic scientists make observations, but those observations are related to things that are possibly of legal importance. Those initial observations may end up being parts of a crime scene or a criminal investigation. Forensic scientists, investigators, and analysts have to come up with logical and reasonable explanations for the things they observe. And if they hold true to science, those hypotheses should be neutral statements, not accusatory ones. In order to show whether their hypotheses are good or not, forensic scientists, like all other scientists, have to ask questions and collect data. And if the results of their tests disagree with their original hunches, then regardless of what they would like to believe, honest and competent forensic scientists have to abandon their initial direction and come up with another plausible explanation for what happened. But that secondary hunch also has to be tested and analyzed. If we're to trust in any form of science, we have to believe that the people doing the observations, the testing, the analysis of results, and the interpretations of data are as objective as humanly possible. I mean, we all know that human beings have our biases, but good investigators and scientists need to do everything they can to leave those biases behind when they cross the threshold of the crime scene, the lab door, or when they walk into the courtroom. That doesn't mean we can't use our heads and consider the most likely possibilities based on our experience. But experience isn't the same thing as bias. It also doesn't mean that crime scene investigators can't act on a hunch or listen to their gut. There's a big difference between theories and expectations based on training and prior experience, as compared to developing hypotheses that are based on unfounded, preconceived, or ill-conceived notions. Okay, I'll get off my soapbox now and try to get us back more specifically to forensic science, which, by the way, is not the same thing as criminology. Criminology is more of a sociological study of crime, criminals, and victims. A person might enter criminology through the behavioral sciences to study the sociology and psychology behind criminal behavior. Forensic science is also not the same thing as criminal justice. Graduates from criminal justice programs typically work in law enforcement, including in police work and corrections, not in forensic labs. In fact, I sometimes have a difficult time convincing students that the best preparation for forensic science is a broad-based background that combines biology, chemistry, and physics. Law enforcement officers are still heavily involved in crime scene investigations, and in my opinion, they're the real heroes in terms of solving crimes, because they're the ones that put the parts and pieces together. But today, the bulk of the analysis of physical crime scene evidence falls to scientists. As technology has advanced the field, a strong foundation in lab sciences is really the basis for today's forensic careers. And the really cool thing about science as a process is that it's truly universal. Once in Guatemala, I got to work side by side with Guatemalan archaeologists who were exhuming mass graves from political conflicts that led to Mayan genocide. And even though we didn't speak the same language, we carried out the process in the exact same way. There's a real beauty to the standard ways of doing things that are recognized by everybody involved, and the scientific method is just that. Even little kids are scientists, in the sense that they use their version of the scientific method to explain what they see. They examine things, and they test people. How does it work? Put it in your mouth. Even better, poke it with a stick. You all know that poke it with a stick is the original scientific experiment, right? Kids constantly ask, why? That is, until parents or the educational system drums that out of them, right? But keep in mind, the explanations people come up with for the things they observe do vary, depending not only on their age, but also on things like their cultural and educational background. I mean, people once thought the Earth was flat because the horizon looks like a straight line, right? And people used to think that evil spirits caused disease. While that may not seem very sophisticated to us, it's still an attempt to explain an observation. So science is a mechanism for understanding the world around us. And it's not only international, it's universal and as old as human history itself. So, to put all this together, a forensic scientist is supposed to use the scientific method in an objective attempt to explain what's gone on in some kind of issue that's open to legal interpretation. And while science is science around the world, what's seen as legal or illegal behavior is linked to a person's culture. What one group considers the norm, another group might consider terrible. Legal systems and laws vary around the world. That's because laws are political and cultural constructs. Laws and legal systems change over time as cultures evolve and exchange ideas. The purpose of this series is not to debate legal issues or to try to explain how or why cultures vary in what they consider moral or legal. Our focus won't be to study crime, criminals, or legal systems. We're here to talk about how science is applied in legal settings and to try to address how evidence is gathered, tested, and considered regardless of what a given culture considers right or wrong. So let's stop and have you think for a minute about the first time you really remember hearing about forensic science. If you're reasonably young, you've probably grown up with that term as part of your standard vocabulary. But if you're over the age of about, say, 35 years old, you probably did not grow up with the term forensic science as part of your vocabulary. The forensic science craze in the United States is really not that old. In my opinion, and I'm not alone in this idea, one pivotal event in United States legal history almost single-handedly catapulted, I mean rocketed, forensic science into the eyes, ears, and minds of the general public. Think you know what it is? Have any guesses? Think about it for a minute. Okay, I'll give you a hint. The event occurred in 1995. Still don't know? How about this? Although it was a single event, it lasted from late January through early October of that year. Come on, still don't know what it is? Okay, I'll give you a couple more clues since forensic science is all about clues, right? The event surrounded a couple of high-profile murders, and the accused was a very well-known American figure. Got it yet? Now, if I mentioned a low-speed chase in a white Ford Bronco along a California freeway, you will most likely know the answer if you haven't guessed it already. The event I'm talking about is the infamous trial of the infamous American football star and sometime Hollywood actor, O.J. Simpson. That highly publicized and televised 9-month ordeal was the beginning of the forensic science explosion that began in the United States and has spread like wildfire throughout the popular media ever since. During the many months of testimony, a bunch of forensic scientists took the stand and spoke not only to the judge, the jury, in a packed courtroom, but also to a riveted public who all of a sudden were fascinated with science and how it could be used, and some say abused, in order to demonstrate guilt or innocence. An entire lecture series could be devoted to the Simpson trial alone, and as of today, nearly 200 books and probably hundreds of thousands of articles have been written about it. It's often been referred to as the trial of the century. This case had all manner of forensics brought up as evidence. There was the bloody glove that created the famous line, "If it doesn't fit, you must acquit." There were bloody footprints said to be made with extremely rare and expensive Bruno Magli shoes. The evidence included hair analysis, autopsy results, bloody socks, carpet fibers, prior offenses, and DNA profiling. The trial was a showcase for some really dramatic testimony and a handful of savvy and flamboyant attorneys. There were accusations of racial bias on the part of a key detective in the case. And of course, the allegations of evidence tampering that probably ultimately led to Simpson's acquittal. I mean, this case had it all. Regardless of how you feel about the outcome of that trial, no one can question the impact it had on the public perception and general awareness of the field of forensic science. And one thing that the public learned from the evidence presented was that there are many different specialties and many different experts involved in forensics, and that the legal system has rules that govern the presentation of both facts and opinions at trial. Of a typical forensic case, though no two of them are the same. There are different types of evidence, there are witnesses, there's the requisite bad guy, there are representatives of the legal system, and a whole bunch of different forensic scientists. In any forensic case, to get us back to the scientific method, an observation begins the investigation, whether it's the discovery of human bones, a burglary, a hit-and-run accident. The identification of some piece of evidence or some event signals a possible crime, and that starts a chain of analysis. The initial observation causes investigators to develop hypotheses to explain what they see. Lots of different types of evidence and expertise come into play as forensic investigations unfold in a real interdisciplinary effort. And when enough scientific evidence points to a particular suspect, that allegation can lead to a trial. So, how will this course unfold? Well, first we'll take a look at different types of physical evidence that might be indicative of criminal activity. Things like fingerprints, firearms, hair, body fluids, DNA, drugs, question documents. Then we'll see how complicated events unfold through analyzing things like blood stains, vehicular accidents, and explosions. Then we'll turn our attention to the science of death and decomposition and see how experts conduct death investigations and look at bodily evidence. Then we'll change gears a little bit and talk about investigation processes, criminal profiling, and using behavioral sciences to get at motive. And we'll take all of this evidence to the courtroom and see how forensic science is used at trial. Although my focus will be on the science behind forensics, as time allows, we'll look at specific cases. In fact, we'll wrap things up with a couple of segments that showcase the ways in which forensic science has been used to solve specific crimes and to assist in mass disaster investigations and to identify unknown persons. Along the way, I hope you'll learn a lot about the many ways that science is used in the pursuit of justice, so you can bust the Hollywood myths yourself when you see them on TV. So let's do another introductory lecture now, one on crime scene analysis, as we make our way toward a better understanding of forensic science.